Today's lesson is about the concept builder rocking the boat, and we're only going to focus on the apprentice level today. In the first question, you're going to have to tap on the picture, click on the picture to change the position of the boat to pick the correct diagram. Just like that. I'm going to exit out of the concept builder now though, because I'd like to show you in more detail information on my notepad. So this box right here will be the first question that you see. And it's going to give you information about two boats that are anchored in the harbor. The boats are going to be bobbing up and down as waves enter the harbor. And for the very first question, the key information is kind of in the middle of the paragraph. When one boat is at its highest point, the other is at its lowest point, and there are no wave crests between them. So you can see that you have boat number one at the highest point, right? It's at the top of a crest. And you have boat number two at the lowest point, the bottom of a trough. And notice there are no wave crests between them in this picture. Now let's suppose I had boat number two at this location. Well, you would have boat number one at its highest point. You would have boat number two at its lowest point, but you would also have one wave crest between the two boats. Okay, if I had boat number two right here, again, boat number one is at the highest point, boat number two is at the lowest point, but now do you see there are two wave crests between them? Okay, well, for this problem, we don't want no wave crests between them. So this is the correct picture. If you picked check diagram, you'd get a dot away. One other thing I'd like to point out to you is if I had the second boat here, this picture would not work. You don't have any wave crests between them, but boat number one is at its highest point and boat number two is at its highest point. You don't have the second boat at the lowest point, so that's why that picture wouldn't work. Okay, so now moving on to the second question, you would get this same paragraph, but now you have to answer a whole bunch of questions about the wave itself, the wave entering the harbor. So what we need to figure out, the wavelength, the frequency, the period, the amplitude, and the speed of those waves. And so let's refer to the very first sentence. Two boats are anchored in the harbor separated by a horizontal distance of 12 meters. So here's your first boat, here's your second boat, and notice the horizontal distance between them is 12 meters. Well, we're going to answer the question about the wavelength of this wave here based on this boat information. And here's what I want you to keep in mind. We've identified a crest and a trough as taking up the space of one wave. Right, so if we have a crest and a trough as one wave, then, here, let me draw the crest and the trough again. If I were to cut that in half, you can see that the crest is half of a wave and the trough is half of a wave. Half and a half makes a whole wave. Well, let me draw the picture yet one more time. Crest, trough, And now I'm going to take the crest and I'm going to divide the crest in half. And I'm going to take the trough and I'm going to divide the trough in half. Well, half of a half is a quarter. So this part is a quarter of a wave, and this part is a quarter of a wave. And here we have a quarter of a wave and a quarter of a wave. So now let's go back to our picture. This part here is a quarter of a wave, and this part here is another quarter of a wave. So it looks like the 12 meters is taking up the space. A quarter and a quarter of a wave make a half of a wave. We can say a half of a wave fits into 12 meters. I've kind of lost my 12 here. Right, we said that this was 12 meters. So I can multiply both sides by the reciprocal of that fraction and get that lambda, the whole wave. 12 times 2 is 24 meters, right? If 12 meters takes up half of a wave, then the whole wave from here to here would take up 24 meters of space. So the wavelength is 24 meters. Okay, let's continue to fill out information. We've already utilized this middle part here earlier when we decided upon our picture. So we're done with that information. Let's take a look at the next sentence. Each boat makes exactly 2 complete up and down cycles every 10 seconds. So 2 cycles for every 10 seconds. Hopefully you're noticing the unit cycles per second. Remember, cycles isn't really a unit. We'll put a 1 in its place. A per second is a hertz. And so this is frequency information. And 2 divided by 10 is 0.2 hertz. Now, to get the period, if you know the frequency, you can inverse the frequency to get the period. So 1 over 0.2 is 5 seconds. Sorry, my cursor was here when I copied the picture, so just forget about that little line. So there's another way you can get the period, though. You could say, oh, it took 10 seconds to make 2 complete cycles. So you also could have said 10 seconds per 2 cycles. And so that's also 5 seconds per cycle. And a cycle really isn't a unit, so that gives you 5 seconds. And then finally, the last piece of information is we have the vertical distance between a boat's highest point and lowest position. So from the highest point to the lowest point. So from the highest point to the lowest point. They're giving us that distance is going to be 2.4 meters. But if you remember, amplitude doesn't measure from the highest point to the lowest point. Let me make my picture a little bit bigger. Amplitude is measuring from equilibrium to the top of the crest or equilibrium to the bottom of the trough. So you're going to have to take this total distance and divide it by 2. Right, 2.4 divided by 2. It's going to be 1.2 meters. So that's 1.2, and that's 1.2. So the amplitude is going to be 1.2 meters. And finally, to get the speed of the wave, well, v wave speed is equal to wavelength times frequency. So we have 24 times 0.2, and that gives us 4.8 meters per second.